Yo, what's going on, guys? Gonna be working on some data structures and algorithms today. Gonna be working on some data structures and algorithms today. I think I can turn the music up a little bit. 20%. I think that's cool. All right. Cool. This is how this is going to be structured. Let me turn this down. Nah, I think that's cool. That's cool. I'm just going to follow the neat code roadmap. I'm starting completely from scratch. And as I go through this, I'll kind of implement everything and I kind of like do my own research because I don't actually own his course. So let's see, what do we have up, right? So let me go to his courses. Just want to look at the curriculum and see, right? So we have static arrays, right? Remove duplicates from sorted array. Okay, given an integer num sorting in non-decreasing order, remove the duplicates in place. That such each unique element only appears once. The relative order of the element should be kept the same. Then return the number of unique elements to nums. Consider the number of unique nums to be k. To get accepted, you need the following things. Change the nums such that the first k elements of nums contain the unique elements in the order they were present in nums initially. The remaining elements of nums are not important, as well as the size of nums. Return k. Okay. So your function should return k equals 2 with the first two elements of nums being 1 and 2 respectively. It does not matter what you leave beyond the return k, hence they are underscores. Okay, so all I'm doing is just removing the duplicates, moving all the duplicates to the beginning, right, to their position relative to the order of the numbers, right? Because they are in increasing order. Okay. And then I need to return the amount of unique elements. Okay. So let's try to break this down, right? Don't clown me. Kind of new to this data structures and how the algorithms thing. So I'm thinking we loop through the array, right? We need to loop through the array. Loop through the array. Okay, so what we also need is we need to keep count, not keep count, but keep whatever the current number is, right? Whatever, because there could be duplicates, right? So from the first example, we take the 1 and move it into the 1th index, first index, I guess. So we have to keep track of what position we're on, right? And as we loop through, we can kind of see, okay, has the number changed from whatever number that we have saved in a variable? And if it's different, then we implement our current index that we want to insert the next number in by 1. So we need to keep track of, I guess, current index, right? That'll be set to 0 at first, right? And then we need to keep track of, I guess, the current number, right? Or do we? I don't think we do, because if we check, because we'll loop through the array using a normal loop, right? We can check if the number at that index equals the number at the current index, right? And if it doesn't, then we replace that number with I guess, yeah, let's just keep track of it, right? So we can say current value Each time we come through here, we check. What do we want to check for? We want to check if nums of I is equal to, well, I guess if it is not equal to current value, what do we want to do then? Oh, we also need to keep track of just want to keep track of k, right? And that'll be 0. Right? And if that's the case, we want to increment k, right? So we'll say k plus or equal 1. And then also sorry. Okay. Okay, two-pointer approach. Okay, I saw something about that. Am I even ready for this question? Let's see. So I have this handy dandy thing called oops. I have this handy dandy thing called recall, which can take the video and produce it into a summary. Let's look at the detailed summary. Dynamic arrays. Okay. Let's go here. Go. All right, we're gonna go ahead and watch this little short video on static and dynamic arrays. Goodness, that is loud.
Was feeling so stuck.
Welcome to CodeFight's interview practice. In this video, we will review one of the simplest data structures, the array. Arrays are used to store variables, and the information is indexed to allow easy lookup. In this array, we would say the yellow marble is at index 2. By knowing where the array starts in memory and the size of each individual variable, it is easy to use the index to find the variable immediately. If we want to check the color of the marble at index 3, say, we can start at the beginning of the array, move down 3 spaces, and discover that the marble with index 3 is blue. It is important to distinguish the difference between accessing an element by index and trying to find a specific element. We have already seen that checking the color of the marble at index 3 is fast, but to try and find a blue marble in the array requires going through the array one element at a time. The simplest type of array is a static array. As the name suggests, their size cannot be changed. Because of this, we cannot directly add an element to a static array. We can achieve the same effect by making space for a larger array, creating the new array, copying elements over from the old array, and then deleting the old array. Deleting an element is the same process in reverse. First, we make space for the smaller array, create the new array, copy the desired elements over, and delete the previous array. If we are frequently adding or removing items from an array, our program can spend a lot of time copying elements between arrays in memory. A dynamic array is one way of addressing this issue. A dynamic array reserves a larger amount of space than it needs, while also storing its size. When we want to add an element, if there's space, we can put the element in while increasing the size parameter. If we want to delete an element, we can remove it while decreasing the size parameter. Of course, if we add too many elements, we can still run out of room, and we have to increase the size of the dynamic array. This involves the same copying process as a static array. The advantage is that we don't have to undergo this process every time we change the number of elements, only when we run out of room, or when we are worried we are using too much space. The advantage of using a static array is that we only use as much memory as we need. The advantage of a dynamic array is that we're able to add and remove elements quickly. Be sure to check out CodeFight's interview practice for more information about arrays and to practice solving real interview questions about them.
So, not to be dramatic, but my life would not be the same without my Curology. Don't wait for the skin you want. Definitely sign up for.
Okay. Hash usage. Okay. Need to learn hash usage, hash implementation, and prefix sums. Okay. Okay. So I guess what I can do, I can just ask ChatGPT and give me a set of to complete to
Hi, this is Scott.
And this is Josh from Lead Dev. There are two types of variation for this algorithm. The first variation involves having a slow pointer and a fast pointer that moves at a different pace. These are more commonly used in linkless problems, and we'll talk about them in future videos.
The second variation involves having two pointers, one at the front and one at the end of the array. We will gradually move one or both of the pointers toward the center. Now that we know what the algorithm looks like, let's apply it in an interview.
A common two-pointer interview question that comes up is 2-sum and its harder variation 3-sum.
So, how common do you mean when you say common?
I'm glad you asked. I once had a full interview loop where two separate interviewers asked me the same exact question. Feel free to pause the video and slowly read the prompt yourself. Given an array of sorted integers, find two numbers that add up to a target number.
Like any good interview candidate, we should never jump straight into the code. Instead, we should have a conversation with the interviewer to come up with an optimal solution. You can't pass an interview if you aren't solving the right problem. The first thing you should always do is ask clarifying questions. Some examples include, what does my input look like? Will the sum cause integer overflow? Let's assume that the inputs are valid. For example, we don't have to do any null checks.
In interviews, it's okay to start off with a brute force solution. For this problem, we will iterate over all possible pairs of numbers in the array to find two numbers that sum up to our target. The runtime of this algorithm would be n squared. This is because we are going through all n elements of the array and we're comparing them with every other n elements. So n times n equals n squared. However, the first answer we come up with is rarely ever the optimal answer, especially if the runtime is n squared. Now, how can we find a better algorithm? Well, one way is to see if we can get any insights from our naive solution, or maybe even the problem statement itself. Another way is to ask the interviewer for a hint. It's always so much better to get an optimal answer, even if you had to get a hint, than not at all. And finally, my personal favorite strategy is to brainstorm algorithms to use based off of the runtime that you're trying to shoot for. You can pause this video to take a moment to think about this. Now, an improvement from a n squared algorithm would be a n log n runtime. Typically, n log n solutions involve sorting an array, which will take n log n, and then scanning through it to find an answer. Alternatively, if an array is already sorted, we can scan across each.
Wait, what was I doing? Oh, I think I was doing the external link. Okay. So we're gonna reset this. I don't think I was doing the correct problem, right? So given an array of nums, return true if any value appears more than once in the array. Okay, so I guess all I would have to do is just create a map. I mean, these are over arrays and hashes, right? So I could say const duplicates equals new map. I know I just caught like a glimpse of the answer. And I pretty much already solved this, right? So, but it's been a while since I solved it. Recommended you should aim for a solution with O of n time and O of n space, where n is the size of the input array, right? So I can just say for the number of nums. Can I do this in TypeScript? No, I can't. For a number of nums, I can say if duplicates dot has the current number. I want to return true, else after turn false. Let's just run it, see what happens. Number is not defined. Oops, yep. Okay, let's see. I was supposed to get false. Oh, I got false. I was supposed to get true. Okay, let's see how this works, right? So if I'm looping through the array, it'll go to 1. All right, it'll add it to the map. And then I'll get 2. Oh, that's why. I'm not adding anything to the map once I right, so I guess after I want to say duplicates dot set. I take a key and a value. Right, so I guess what I can do is just give it a number and the index. No. Let's see what happens if you use also. I need to check. Let's see his references. I don't really use maps that much. Right? So let me go map methods math.get. You get the value of key in a map with the get method, right? So get apples. Let's see. Get apples and you get 500. Okay, what about has? Turns if a key exists, right? So let me go to set. Let's set this without. And then run it undefined. So, I mean, I guess it's okay. I don't really need a key, but I guess I'll just set it as number. And then now let's try to run it. Okay, here we go. Let's go ahead and submit it. Follow-up question is anagram and 2 integer sum. Okay. Given 2 strings S and T, return true if the 2 strings are anagrams of each other. Otherwise, return false. Crap. Well, I guess I can just come to the ones that I've already been through. Okay, I've already been through this one. Okay, group anagrams. These are mediums. Given an array of strings, group all anagrams together into sublists. You may return the output in any order. We're gonna go back to roadmap. Okay, so group anagrams is in here, right? So I'm guessing I need to go and learn prefix sums.
Prefix sum, a super useful lead code pattern that can optimize the time complexity of many array-related problems from order of n square to order of n. If you go on lead code, there are currently 173 problems tagged with this pattern, which shows just how important it is. In this video, you will learn what a prefix sum is, how to implement it in code, when to use this pattern, and I will walk you through multiple problems. Just a quick note, if at any point you feel like pausing the video and trying the problem yourself, I encourage you to do that. First problem is lead code 303 range sum query immutable. Given an integer array, answer queries that ask for the sum of elements between 2 indices. A brute force approach to solve this would iterate from the start to end index for each query. However, this can take O of n time per query in the worst case, where n is the number of elements in the array. We can optimize this to O of 1 time per query using the prefix sum approach. Here is how it works. In the constructor, transform the input array into a prefix sum array to avoid using extra space.
Building your online business? Go to Wix.com.
Hey guys, welcome to another video. Today we're going to talk about prefix sum. As the name suggested, prefix sum is just the sum of the subarray of the prefix subarray of the original array. So let's say we have an array A that look like this. Okay, really simple array. And let's say we want to construct the prefix sum array of A. So the first position is going to be 1. The second position is going to be the sum of the first two values, which is 3. Then the third position is going to be the sum of the first 3 values, which is 6. You figure that the next value of the PSA is actually just the sum of the last value of PSA, which is 6, and the next value of A. So add up these two, you get 10, right? And 10 is the sum of the first 4 values of A. And 15. So this is our PSA. So what is the point of building the prefix sum array? The point is, it can quickly give us the sum of any subarray of A. Let's say we need the sum of the subarray that contains 2, 3, 4. Okay? So without the PSA, we have to add up 2 and 3 and 4 and get 9. It's actually going to take us big O of n time, which is quite slow. But if we have PSA, all we need to do is to subtract 1 from 10 and get 9. So why is that? 10 is the sum of the first 4 values in A. Okay? And 1 is the sum of the first value itself. So if we do the subtraction between these two, we're going to get the sum of the second value up to the 4th value, which is 2 plus 2, 3 plus 4, which is 9. Right? So that is the best benefit of using the PSA. And the cost is that we need an extra space to build the prefix sum array.
You always wondered why that app didn't exist. Now you can make it. Meet Replit Agent.
Hey everyone, today we're going to talk about prefix sum arrays and how to answer range sum queries really fast. Imagine you're given an array of integers and a lot of queries asking you what would be the sum of all the integers in the given range. How could you answer those types of queries as fast as possible? Let's look at an example. Say we upload this video to YouTube and would like to know how well it performed on any given date range. Let's imagine that on the day of uploading the video, it got 8 likes, so we add 8 to day 0. On the next day, 3 people liked it, and the day after, 2 people liked it and 4 people disliked it, so we subtract 2 from the score, and so on. So for any given date, the score of the video is the number of likes minus the number of dislikes the video got on that particular day. And now we would like to know how well the video performed from day 2 to day 7 or from day 3 to day 6, and we would like to answer those types of queries as fast as possible. Well, the naive approach would be to iterate over all the days in the given range and sum those numbers together, right? So if the query asks, how well did the video perform from day 2 to day 7, we'll start from day 2, then move to the score of day 3, then to 4, up until day 7, and sum those values together. If we're asked to calculate the video performance from day 3 to day 6, we would start from the day 3, and then move to day 4, then to 5, then finally to 6, and sum those values together. But this approach is very slow and requires performing a lot of redundant operations. So, to come up with an algorithm that can answer these queries faster, let's first simplify the problem a little bit. So, imagine that all the queries ask what would be the video performance starting from the first day. So, in other words, what would be the sum of all the numbers starting from the day 0 up until the query day? This is a little bit easier to answer, and we'll soon see that there is only one extra step required to answer any kind of range queries if we can answer this one quickly enough. Imagine there are many queries asking you what is the sum of all the numbers from day 0 up until the query day. Again, let's look at the naive approach. If the queries ask you about the performance up until days 3, 5, 2, and 7, we can loop through all the numbers for each of the queries and add the values in our initial array together. So for 3, we would calculate A0 plus A1 plus A2 plus A3. Then for 5, we would calculate A0 plus A1 plus A2 plus A3 plus A4 plus A5. For 2, we would sum up A0, A1, and A2. While for 7...
I'll be right back. I need to go use the bathroom. How the Alrighty.
Which is very slow and requires performing a lot of redundant operations. So, to come up with an algorithm that can answer these queries faster, let's first simplify the problem a little bit. So, imagine that all the queries ask what would be the video performance starting from the first day. So, in other words, what would be the sum of all the numbers starting from the day 0 up until the query day? This is a little bit easier to answer, and we'll soon see that there is only one extra step required to answer any kind of range queries if we can answer this one quickly enough. Imagine there are many queries asking you what is the sum of all the numbers from day 0 up until the query day. Again, let's look at the naive approach. If the queries ask you about the performance up until days 3, 5, 2, and 7, we can loop through all the numbers for each of the queries and add the values in our initial array together. So for 3, we would calculate A0 plus A1 plus A2 plus A3. Then for 5, we would calculate A0 plus A1 plus A2 plus A3 plus A4 plus A5. For 2, we would sum up A0, A1, and A2. While for 7, we would need to add all the numbers from A0 up until A7. Notice how the first part of the computation is always the same. Before calculating the result for 5, we already knew the result for day 3. Before calculating the result for day 7, we already knew the result for day 5. So there's definitely some room to optimize this. To do that, let's calculate the performance result for all the days starting from day 0 up until the last day available. Let's call the resulting sum P, which stands for the prefix sum. So each element of P would represent the sum up until that day. So answering a question like what is the result of the video performance up until day 7, we can just print the value stored in P at location 7. So let's calculate the array P. The first element of P is equal to the first element of the given array. The second is the sum of the first 2 elements. The third is the sum of the first 3, and so on up until the last element of the array. Did you notice the pattern? To calculate the next element in the prefix sum array, we repeat all the actions in the previous one and then add only one more element from the initial array. Well, as all the actions are already stored in the previous element of the prefix sum array, we can just reuse it. So the prefix sum array can be calculated with a single for loop. We can initialize the first element of P to be equal to the first element of A, and then for all the next elements from 1 to n, the elements of P will be equal to the sum of the previous element and the corresponding value in the array A. Now, if anyone asks, how was the performance of the video up until day 6? We can just print P6. Or if they ask what was the performance of the video up until day 8, we can just print P8. So we pre-computed some values which took us n operations, and now we can answer any query with only one operation. Now let's go back to the initial question of obtaining the video performance for a range of days. So given many queries of the form from L to R, we would like to know how the video scored starting from day L up until day R. You can pause the video and think for a little bit to come up with the final answer yourself. If we know the performance of a video from the time it was uploaded up until some day X by just accessing an element from the prefix sum array P of X, then we can get its performance up until day R and get its performance before day L and subtract those two values. So the sum of any range from L to R would just be P of R minus P of L minus 1. But wait, as you can notice, when we subtract P of L minus 1 from P of R, if L is 0, L minus 1 can get negative, right? There are two ways of handling this. You can write a separate if statement for that case when L is 0, or a more elegant solution would be to add an additional 0 at the beginning of the arrays. This will make sure that we don't hit a case where L is 0. So we need to update our calculations and get the answer by subtracting P of L from P of R plus 1. So implementing this would look something like the following. This small trick helps eliminate some if-else conditions and have a clean and concise code. Oh, by the way, you can get some hands-on practice with prefix sum arrays by going to Profound Academy and solving several problems using the technique we just learned. Link is in the description below. Now let's see the algorithm in action. First, we calculate the prefix sum array with the initial element being 0. Afterwards, each element is equal to the sum of its previous value and corresponding element in the initial array. Now we can answer any query with only a single operation. To know the sum of elements from the second position to the fourth one, we can just subtract p of 5 from p of 2. To know the sum of the range from 5 to 8, we can subtract p of 5 from p of 9. Even the ranges including 0 are perfectly handled, and getting one element as well. As we add 1 to the right border, we can safely calculate the value of a single element using the prefix sum array. So, getting the value for any range is just a single operation of subtracting two values, and therefore we can answer each query in all of one time. In total, if we have n items in our array and q queries, we would perform n operations to get the array, pre-compute the prefix summary, and q operations to answer all the queries. So in total, the time complexity of the algorithm would be O of n plus q, while the memory complexity would be O of n, as we hold the initial array and also create a new one that has a length of n plus 1. This was it for prefix summaries. Thanks for watching, and I'll see you in the next one.
So what I'm going to do to kind of practice this, I'm going to come into, I'm going to open up a new file. Go to projects, practice projects, new folder, call it DSA implementation. I'm only focusing on prefix sum, not the range sum queries right now. Come in here, create one, call it PSA. No, prefix sums array.ts. I don't know. I'll just do JavaScript for now. And I'll just say const test test array equals, we'll just say alrighty. Alright, so just gonna have ChatGPT. Okay. It's going to take in an array. So say nums. Say const. I'll say 4. Okay, so how does this work? Right, so go to Obsidian. Go to software engineering. Now let's create a new folder. I hate that I have to install my plugins. Browse, Excalidraw, install. What is this? Oh. Enable it. Okay. I'll just call this right, algorithms visualize. Just delete that. All right. And Jesus. Okay, so how this works is we start out with say 1, 6, 12, 5, 10, and then let's say 20. All right. Then we come down here, right? And as we loop, we'll cross one out. All right. So our first iteration, we start with 1. And then we take the 1 in the current iteration. Okay, so we take the previous iteration and the current iteration and add them, right? And then save that to that, right? Then we take the current iteration or the current iteration and the previous iteration. So 7 plus 12 will be 19, right? Current iteration, previous iteration, 24. Current iteration, previous iteration, 34. Current iteration, previous iteration, 54. Okay, I think I got this. So all we have to do is just loop. Say let number of nums. Or I guess we have to do it like this, right? So let I equals 0. I is less than nums dot length, and then I plus plus. And then first, what we got to do is check if it's the first element in the array, right? So I'll check if I say nums I can't say if nums is equal if nums of I minus 1 is equal to undefined, then new array dot push, and we just want to push nums of I, right? Or what we can do is start out the array with the actual first item already in it, which probably saves some performance because then we wouldn't have to check every single iteration, right? That'd probably make more sense. Right, so I'm gonna say nums of 0. And then I can really just start this from 1. Right, and then I can say new array dot push, and then we'll say new array. So we want to, no, don't give me that. And say I minus 1 plus nums of I. Is there anything else we have to do after that? Let's just return new array. And then we'll run console log. Guess we'll run prefix array equals get prefix array, and then we'll pass in a test array, and then we'll just console log prefix array. Let's see what that does. All right, so we'll go to node. I guess what I'll do is do this, so I don't actually have to npm init. Just npm install node mine. Into my package, and then we'll say start. And then we'll say node mine. I guess we'll just change it as we go along. Hmm. I guess we could just run it. So we got 0, 7, 12, 15. Here's what I do just for confirmation. Say new array minus 1 plus nums of I equals okay. All right, I see that as a success. So I'm gonna go ahead and move on to the next exercise they provided me, right? Range sum queries. Given an array and multiple queries of the form ij, return the sum of elements from I to j. Okay, so I think I understand how to do that. All we have to do is subtract j from I. So I'm going to say const let me go here. All right. Cool. Okay, find number of subarrays with sum equal to k, given an array of integers in the integer k. So I guess we're good to go back to the roadmap. I think we're gonna give this a little break. Go work on the project for a bit. See if we can figure that out. All right. Let's see. I have a good feeling about this today. I think we're gonna figure it out. All right. All right. Probably while my node mon wasn't running. Let's try and get bash. See if that works. Let's check if I have node. Okay. Should be redirected to the onboarding page. Yep. Nice. Just trying to get this issue with my node fixed. I don't know what's going on. I have to run it in Bash. I hate this. You know, I pay $20 a month for this crap, and it does this. It didn't used to do this before. Must be a lot of people generating images with this new feature. That feature is pretty good right there. Okay, remove the broken. But I was supposed to run it. Paste it in here. All right, then I need to come back to my environment variables. Edit, new. Just ran this. Bro, this is so annoying, bro. Like, I pay monthly. I shouldn't have to wait 30 minutes. It's making me want to switch to like Claude or something, bro. I swear. Bro, it was literally just working yesterday. I don't get it. It's so fucking stupid. It just works 1 second, then it just stops working. Like, that is so fucking annoying, bro. Yeah, let's try this.